type it in with the superscripts like that. So it's 2 to the x. Now, when we started graphing a long time ago in a galaxy far, far away, the easiest way to start graphing was to make tables. You agree? And you're always going to pick numbers that are easy to work with. So, you might remember this. Let x equal -2, -1, 0, 1, and 2. More often than not, when you guys first learn how to graph lines, you probably use those 5 numbers, because you're looking at what's happening on one side of the x-axis or one side of the y-axis and the other side. Okay? And it just gives you a nice pattern of what's going on. So we use them. Substitute in your values: 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 squared. What do you get? 1/4. Then what? Is that it, Jay?
1/2.
1/2. 1. 2, 4. Not so scary, I'm hoping, right? Yeah, a lot of times it worked out to be like that. So, we plot them. Obviously, a lot of these, you're going to get some fractional ones, so you'll have to kind of fudge it as you're going through. It's not a big deal. We're just looking at the general idea. So you have -2, -2 1/4, -2 1/2, or -1 1/2, 0, 0 and 1, 1 and 2, 2 and 4. So your graph looks like that. Yes, ma'am?
I probably asked this like 3 months ago, but how can you 0 power?
Anything and everything to the 0 power is always 1.
There's no
0?
Okay.
0 to any power is
No. 0 to the power of 0.
Is 1. Yep. Anything. Potato to the 0 power is 1.
Potatoes to towers?
Why not?
That's not how potatoes work.
Aren't potatoes just variables?
No! Potatoes are potatoes are movers.
So what I want you to do is I want you guys to take the calculator out. I'm going to use the calculator a little bit here to show you what's going to happen with this function. First of all, let's put this in the calculator and graph it. Y equals 2 to the x. You didn't bring it to a math class? You didn't think you needed a calculator to a math class? Are you going to share? Or are you going to be a curmudgeon?
Wow, I really appreciate it.
It might be the first time he was nice to you.
And it may also be the last.
Never mind that. So, let me ask you this. What's your domain?
Okay, if you turn that on its side,
X all
that's
real.
what my face looked like yesterday during the final.
Guys, we got a lot to do. What's the domain?
X all
All
real.
real. Is there any value of x that this equation won't work?
Nope.
No, so it's all real. Now, think about what's happening here as the values of x are going negative. As the values of x are going negative, what is the graph approaching? An asymptote. It's approaching 0. Now, does everybody agree that it's getting infinitely closer and closer and closer to 0? Is it ever going to touch 0?
No.
No. So this becomes a horizontal asymptote. When you have a horizontal line, what's the equation of every single horizontal line? Y equals something. In this case, y equals 0. So your horizontal asymptote is at y equals 0, which means now, what's my range?
All positive.
Greater than 0. It's y's that are greater than 0. It's all values of y that are greater than 0. All right? And that's what we're looking at today. Can we plot some few things through? So with your calculators out real fast, what I want you to do is put in these other 2 equations along with the y equals 2 to the x. You've got y equals 2 to the x. Why don't you put in y equals 1/2 times 2 to the x, and y equals 3 times 2 to the x. I'd like you to put in those 3 equations. When you type it in, sometimes for clarification, you can put that 2 to the x within parentheses, but the calculator knows once you raise it, that 2 value to the x, that's what's added to the x. I think I have these in here.
So are we drawing in a graph paper?
No, I just want you to look at them in the calculator real quick. All right, we're just looking at them in the graphing calculator.
You want us to look at the table?
Well, first of all, let's look at the graph. When you graph those, you get those 3. You agree? Good. You have those 3 graphs. Now, when you're looking at these 3 graphs, you can go to your table and you can look at the values that are occurring. The x values aren't changing for any one of these graphs. The x values are still being calculated the same way. -2, -1, 0, 1, 2, 3, 4, and so on. But what I want you guys to notice here, when you're finding a y-intercept, what is your value of x always going to be? 0. You guys okay with that? The y-intercept, your x value is always 0. So take a look at your y-intercepts. When x equals 0, for the next graph where it was 1/2, oh, I'm sorry, I've got my table. Let me reset my table here. So our first graph was y equals 2 to the x, right? Our y-intercept was at 1. When it was y equals 1/2 2 to the x, what was our y-intercept? 1/2. When it was y equals 3 times 2 to the x, what was our y-intercept? Do you notice a pattern?
Maybe.
Maybe. What's that pattern?
I don't know. I said maybe.
It's multiplies by 2.
Well,
For instance,
what is it?
is it the number that's in front of 2 that adds to
That's
the
exactly what it is. That's exactly what it is. Notice your y-intercepts were at 1/2, a 3, and 1. Because I can rewrite that as 1 times 2 to the x. So what's happening here is that there's this multiplier in front of these exponentiated values. I think I made that one up.
I was about to say.
That allows you to figure out your y-intercepts. This is what we call the parent function. These are parent functions.
But all of those are parent functions, or is it just like the
Because what happens after the parent function, what do we introduce them?
Oh, we moved
The
shift.
shift is the h to k. Oh, blessed is right. Y equals a times b to the x. That is the parent function for these exponential growth or decay models. Okay. This value of a is your y-intercept. Okay. You'll start to develop rather quickly here where everything else falls into place pretty easily. So far today, no, it hasn't really gummed up anybody, really. Right. Show you. Rewrite this. So we're dealing with our parent functions. We have it as y equals a times b to the x. There's a couple of rules we're going to look at. For exponential growth, this is our growth rule. B is always greater than 0. And not equal to 1. Why can't it equal 1?
Because that would always be 1.
Because it would always be 1. No, then it would always be a.
Yeah.
Because you're multiplying by a.
Correct. And once again, the question was, why can't it be equal, why can't B equal 1? If B was 1, no matter what power you raise it to, it's always going to be 1. So you have a horizontal line at A. So it'd just be a horizontal line. Therefore, no longer exponential. Yes?
What about like 1 to the negative square becomes 1/2, right?
What's the square root of 1? I like your enthusiasm, but no. Okay. There's a couple of things that happen. Now, let's look at the y equals 3 times 2 to the x. And I want to look at that graph and talk about some parts. And let's graph. So I got out of sequence here. I think I skipped a page. Let's do this. Let's graph y equals 3 times 2 to the x. We already have that in our table. You guys okay with that?
Yes.
So we already have this in our table on our calculator. Got ahead of myself here. I'm just going to bring this over. So this is our table for that. So we would plot it. At -2, it was a quarter. At -1, it's at 1.5. Oh, 3/4, excuse me. 0 was 3. 1, I lost. That's way up there. It's doing that. We okay with that? We know that there's a horizontal asymptote. Where was it? 0. The horizontal asymptote is at y equals 0. The y-intercept was where? 3. Y-intercept was at 3. Is there a vertical asymptote?
Yeah.
If there's a vertical asymptote, excuse me, that means that there has to be some value of x that won't work. Is there any value of x that won't work?
No.
Correct.
It's going forward.
Yep. There's no value of x that won't make this work. You're always going to be able to generate a value. So there is no vertical asymptote. Okay. Exponential functions will not have vertical asymptote. When we get the logarithms, that might be different. All right.
What won't have vertical asymptotes?
These exponential graphs. Okay. Now, what's our domain then? It's all real. Okay, good. And my range for this problem? Y is greater than 0. Good. So as we go through the process of doing some of these problems, guys, what we're going to be looking at is, can we figure out where our horizontal asymptotes are? Can we get our y-intercepts? Excuse me. Domain and range. All right. You're always going to be using the same basic numbers: -2, -1, 0, 1, and 2. They're the easiest ones to work with. You should be able to crank through some of those in your head. Yes, ma'am.
For all of these that are like raised to power, is the horizontal asymptote always 0?
For the parent function, yes. When we shift them, it changes.
Wait, so, but the parent function, like for the last time we did it, that was like a whole separate equation from the thing?
Yeah.
So this isn't the real equation, this is a fake equation.
This is the parent function of the non-shift. I haven't gotten to the shift yet. I want to play around with a few of these first before I go to the shift. All right.
How do you determine that the horizontal asymptote was 0?
Because as this thing is getting smaller and smaller and smaller, it's never going to get to 0 because it's just getting to become a smaller fraction. Okay. And there's no k value.
There's no k values?
Not yet.
It
Now there is.
Wow.
Convenience is right.
That was just rude.
You're so funny on that.
So what we're looking at now is your H and your K. This is what the shift is going to look like off the parent. What do you think the H stands for?
X.
X.
The horizontal, the shifted X. And what is the K?
Vertical.
The vertical. You're right. It's the
Okay.
Y values. Okay. Just like we've done this before, your H is your horizontal shift, and your K is your vertical shift. So this is going to change your X, and this is going to change your Y. I wrote X plus H or Y plus K, but remember that H value could be negative, it could be positive, it just depends. When we graphed those stuff last semester that we had the parent functions, you guys didn't like doing parent functions and shifts because what we were working on were relatively easy just to go right to the shift. What I was trying to get you guys in the habit of doing was plotting out that parent, because as you do that, this semester becomes so much easier because of all the different graphing you do.
So the imaginary ones that we were doing, okay.
Yeah, and this is where this comes into play, all right? So the A, H, and K, the A value is always give you your y-intercept, all right? The H value is always your horizontal shift, and your K value is your vertical shift. Now, we were asking about is the asymptote going to change? If you have a K value that's 3, that means everything moves up 3. So if your parent function has an asymptote at 0, which they all do, whereas your real function can have an asymptote 3.
So K is the asymptote.
Right, so.
When you go with the parent function,
A is always the y
intercept, yes.
intercept.
Alright, so A is one intercept, K is vertical shift, H is horizontal shift.
Yes, sir.
What's B.
B is whatever value.
Okay.
B is going to be greater than 0 but not equal to 1.
And what about X?
I don't know what X is. Solve for it.
Oh, okay.
Not really solving for it, but yeah. So let's look at this. I'm going to start with a non-shifted with a different A value to walk you through what this is going to look like as you do this. Because yes, you're going to work with some fractions, and you're going to have to be able to do some of these problems without the use of a calculator. All right. So if we're going to plot out y equals 1/2 times 3 to the x, we always start by figuring out A, H, and K. Well, what's that? 1/2. So if A is 1/2, where's your y-intercept? At 1/2. We know that our y-intercept for the parent, do we agree that this is a parent function? There's no H and no K? So there's no shift to worry about? Since there's no shift to worry about, we know that your horizontal asymptotes can be where? It's zilch, which is otherwise known as 0. So we know we have a horizontal asymptote at y equals 0. Where's my y-intercept?
It's at 1/2.
It's at 1/2. We know my y-intercept is at 1/2. The rest of it, we need to show how to get the word pairs. And this is where being able to use some fractions, some really easy fractions work out. We're going to do the table again. Pick the same numbers. -2, -1, 0, 1, and 2. Move this over out of the way a little bit. So it's 1/2 times 3 to the -2. 1/2 times 3 to the -1. 1/2 times 3 to the 0. 1/2 3 to the 1. And 1/2 3 to the square. Please, 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 don't forget your order of operations. Please excuse my dear Aunt Sally. What do you have to take care of first? The exponent. So what is 3 to the -2? 1/9.
That's what it's called exponential growth, because you're using exponents.
Yep. So it's 1/9. What's 1/2 times 1/9? Good. What's 3 to the negative 1? What's 1/3 times 1/2? Good. 3 to the 0? 1/2 times 1 is? There's your intercept again. See how that works out? 3 to the 1 times 1/2. 3 halves, good. And then 3 squared. So it becomes 9 halves. Yes, ma'am. It is. So it's tough to write out because I didn't have that much space. But yes. Okay. So when you go to plot those, you've got your ordered pairs listed out. There's no horizontal, there's no vertical shift. Obviously, it's tough to mark out where 1/18 is, but could you say it's about here? Close-ish.
Yeah.
Whatever. This might be a smidge more. This is a little smidgen more. Smidgen more is a town in Minnesota. It's by Bemidji.
Where is yours?
Yeah.
Interesting fact of the day.
It's just each of it. Jenna, there's no such place in
Oh, I was like,
I tried to keep it for the longest. I'm like going,
Just a little bit east.
it's a little bit east. There you
So I
go.
believe the orange thing would be covered.
1 is at 1.5, and then 2 is at 9/4, which is a little bit more than 4.5. So there's your graph.
Thomas made a funny joke. Everyone acknowledged it.
Where do you go, Thomas? I didn't hear it.
It was me, Thomas, I didn't want that.
Oh, Jose said Jenna believes anything you tell her, and I said Jose is good at soccer.
You're welcome.
Ouch. Ouch. I'll give you credit on that one. No offense, but that was pretty good.
We can't keep all the humor in this corner of the room. We gotta share it.
We should switch seats.
No. I wouldn't go that far.
So we're okay with this. There's no shift, right?
Yes.
All right, let me try something different here. Let's do a different one. Again, non-shifted, but what's my value of A? -1. Oh, I forgot to do domain and range. Do I need to do domain and range on that last one? What's your domain? What's your range?
Greater than 0.
Greater than 0. Why is greater than 0? Okay, good. Now,
Is it always going to be that way?
Just remember the
Ish.
change it.
that tape dispenser's broken. In this case here, you have negative times the quantity 3 halves to the x. So what's my value of A?
-1.
-1, good. You'll see that quite often. Well, they'll throw a -1 value out in front just to mess with you. Okay? Now, is there an H and a K again in this case? No. I didn't give you a shift yet, so we're still at zeros for both of them. Now, as you go into this, let's move this over so we can do some ordered pairs here. Again, -2, -1, 0, 1, and 2. Use those 5 values because it's so easy to work with. -2, -1, 0, 1, 2. Now, what I would do is, as I'm thinking this in my head, I'm going to write it as -1 times the parentheses. Okay? Just continually to write that out so that we don't get gummed up with that negative value. See what I said? To share. Oh,
Let me see.
no, whatever.
It's actually French, so it means to share.
They both originate from
That's the word.
Thank you for saving me.
Is this
In
Sebastian?
pluralis uno.
Oh my God,
It looks like Sebastian's handwriting.
This is Sebastian's.
Whatever. Anyway,
The same.
when you have a fraction to a negative exponent, what do you do to that fraction? You flip it.
Okay.
So what is 3/2 to the -2?
2/3 to the.
4/9. What's 4/9 times -1?
Negative 4/9.
Everybody hear that okay?
Yeah.
When you have a fraction raised to an exponent that's negative, you automatically flip the fraction. Okay? Because you're distributing that negative power to both the numerator and the denominator, so you just flip them. Okay? So what's 3/2 to the -1? And what's 2/3 times -1? Good. We already know what our y-intercept here is going to be, right? -1. And what's our next value? -3/2. And then lastly, -9/4. Very good.
I'm so excited when I can do that.
Good. All right, you know what? Here. You want my two, Colette? Just to start off, make sure you get it right. Oh, bless you. Sure? All right. So now we have more.
After finals, I really needed that. I needed this fraction confidence boost.
There, is that better?
Yeah.
All right. Now you've got your ordered pairs to plot. Where's your horizontal asymptote going to occur? Still at 0. So at -2, I'm at -4/9. -2, -4/9, what is that? Almost a little bit more than half?
No, it's a little bit less than half.
Yeah, that's close enough. It's government work, right? -1, -2/3. Whatever. 0, -1. 1, -3/2. And then 2, 9/4 is a little bit more than 2. What direction is this graph going now?
Down.
It's going to the right and down. Now, we've been talking about exponential growth.
Okay.
It's still going from right to left, isn't it? Going from right to left, it's either going to go, exponential growth is either going to go right to left going up or down. That's considered growth. There's a reason why that occurs. It has to deal with the b value. We'll look more about the difference between growth versus decay tomorrow. The graphing of it is the same. The b value is very easy to identify the differences. It's the same no matter what. Yes, sir?
Is this one of those graphs where it has the exact opposite curve, like way over in the other quadrants?
No, this one won't have the opposite one. This one this is not paired out like we were looking at with some of those polynomial functions. This isn't like that.
Okay.
All right, this is just a singular curve. All right?
So, would domain stay the same?
Yeah, your domain in this case is going to be what?
All real.
All real. Your domain is all real because it doesn't change for that. What's your range though? It's less than 0. Why is less than 0? Great movie if you ever get a chance to watch it. The reason why it's less than 0 is what's your a value? It's negative. It's just moving downward. The a value tells you it's going to be greater than 0 if it's moving upward, or downward, it's going that way. That's how you're able to tell that out. Does that make sense? All right, we'll shift one. Oops. Let's shift one. Y equals 3 times 2 to the x minus 1 minus 4. Let me write this back. Man, he's just piling Jose Day. Wow. Man, that's brutal. We do the exact same thing. When we go to start this shift graph, we're always going to identify A, H, and K. So what's A?
It's 3.
3. What's H?
Plus 1.
Plus 1, good. And then K?
-4.
-4, good. You guys caught that. Good. You guys remember the rules with the opposites and stuff like that. Perfect. That's what I was hoping.
always hope.
You can always hope. Now, when you go to plot something that has a shift to it, you want to plot the parent. We're going to plot the parent graph first, because off of the ordered pairs of the parent, everything moves right, left, up, and down. That was the idea behind doing the shifts with the parent graphs last semester. Because every time we graph something that has that H and K, if you were able to identify your original ordered pairs, the shift is a piece of cake. It really is, okay? It really gets easy. So pick out your values. -2, -1, 0, 1, 2. What? Just go the distance. Go for speed. Don't be all alone in your time with me. I know I'm changing the lyrics, and I knew you were really already for Hi, everybody. Really, I get it. You're mouthing off to me behind my back. It's okay. I understand.
I'm just so scared. What? I do math for 1 minute in this class.
I was doing a cake song reference.
I want a cake song.
All right. What's 2 to the -2?
1/4.
1/4. What's 3 times 1/4?
3/4.
Good.
I got it right.
All right. What's 2 to the -1?
1/2.
What's 3 times 1/2?
No.
Wait, what's the first one?
3/4. Sorry.
C. Backwards C over 4.
What was this one? 3 halves. What's the next one? 3. Are you okay with that?
Yeah.
So now, on the parent graph, where's the horizontal asymptote?
0.
It's at 0. The horizontal asymptote for the parent function is still y equals 0. All right? I plot these sets of ordered pairs. -2, 3/4. -1, 3 halves. 0, 3. 1, 6, 2, and 12. I just have to move it off my graph. Now, remember when we did this last time around with the parent function stuff? We would write out that your shift was x and y. Now, our horizontal shift is to the right one. So am I adding 1 to the ordered pairs, or am I subtracting 1s to the x values? Adding. So my shift would be at whatever the x value is plus 1, and the y value would be -4. You okay with that? So this is what your shift ordered pairs would look like. I know that some of you like to rewrite your ordered pairs out. By all means, get in the habit of doing that. There's nothing wrong with that. It's not that bad. But for sake of time, I'm just going to walk it on my graph right now. All right? I know that this point's got to go to the right 1 and down 4. 1, 2, 3, 4. To the right 1 and down 4. 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. Right 1, down 1, 2, 3, and then it winds up at 8. And what do I have to do to the horizontal asymptote? Move it down 4 so it becomes at -4. So our new asymptote is at y equals -4, and here's my curve. And that's what those look like.
What about K, the vert shift? Or is that?
The vertical shift is how you move your horizontal
Oh,
asymptote.
it doesn't mean like vertical asymptote?
No, the vertical shift, yeah.
I
Vertical
thought like
shift.
you were introducing.
No, we don't have vertical asymptotes with exponential growth problems. Exponential growth decay, there are no vertical asymptotes. There's horizontal asymptotes, the y values. There's a boundary at the y value, okay?
Yeah, I heard you say, I thought that we were introducing. that
Oh.
for some reason.
No. I'm sorry if I misspoke.
Okay, thank you.
What's your domain and range now at this one?
Domain all real,
Domain all real.
y is greater than -4.
Perfect. Your domain is all real. Should never get that question wrong with this. And then our range is y is greater than -4. Remember, this k value will be your horizontal asymptote. Yes, ma'am.
When we are learning this kind of stuff, will domain always be all real when we're learning this kind of stuff?
Exponential growth and decay, yes.
Okay.
We'll have vertical asymptotes eventually with logarithms. It's a different set of style, it's a different style of a problem, but it still has h's and k's, and it's still very easy to identify where they're going to occur. Okay? It's very, very simple. All right? Because they all follow the same pattern, basically. All right? Not so bad, is it? No. All right. I want you to do this one, but I'm going to change this a value out front. I want to make this a -2 times 2 to the x minus 3. All right? Give it an a value of -2. And we'll go through this one. I'm going to give you a couple minutes to start on it, and I'll have to finish it up, but quick here. What's your a, h, and k, guys?
-2, 3n plus 1.
So we know in the very end that you're going to have a y, your parent function has a y-intercept at -2. You also know that your final function will have an asymptote where?
It's 1,
At 1. Is it x or y equals 1?
y.
Good. So pick out your values real fast. You're going to substitute in the -2, 2 to the x minus, excuse me, 2 to the x. -2,
1
-4,
fourth.
0, 1, 2.
Yeah, 1/4, 1/2, -2, -4, -8.
Thank you. What was it, -2, -?
4, -8.
Thanks. All right. So your parent function winds up with those sets of ordered pairs. You plot them through.
Can't you just add or subtract the h and k once they're already there and then plot them?
Whoa.
Yeah.
I might have done something wrong.
Yeah, you got
Sorry.
these values here.
Sorry.
So this would have been 1/4 b. No, this is all.
I messed up. Sorry.
No,
Yes, it's -2 times 1/4 is -1/2.
Yeah.
Sorry, I'm not listening to you anymore.
Well, it was your fault to listen to me in the first place.
What's that?
It was your fault to listen
What?
to me in the
Are
first
you
place.
talking?
Yeah.
I'm just throwing it out there. This is -1, -2. What is this? one? Thank you.
I mean, you know my grade from last semester, so.
All right, so -2, -1/2, -1, -1, 0, -2, -4. All right, remember, when you plot your parent functions, make them dotted lines, because they're not really there. To this, you got to move them to the right 3 and up 1. Got it. It is not cheating. And then where is your new asymptote going to be? Your new asymptote will be at y equals 1. Let me give you a couple of these to try out for tonight, because I know we're running out of time here. I want to look at just this top grouping. Tomorrow we'll go over a couple of them, and I'm going to show you the difference between decay and growth. It is very, very easy. The process to what we did, everything today, is exactly the same, except the b value changes. That's the only thing that changes with decay. Tomorrow, we won't take 35 minutes to go through the whole lesson. It should take 15, and I'll give you guys some time to work. All right? Sound fair? You need more graphic, please. There's plenty of it lying around. Yes? The difference between the b values and the b values but they're not like 3 halves. That's right. It'll be like 1/2. And so instead of it going up and right, it's going to go left and up.
I really
That
want
makes
to
sense.
reach
And you do the same thing where you pick out those easy numbers, the negative, negative 1, 0, 1, 2, 3. H curve, they used to say, I just want to make sure you're all right. That's all. Okay? All right. Oh, yeah, let's listen to you.
They just believe in everything people tell you.
Sure, why not?